Okay, so for Calculus Chapter 2, number 19, I'm not going to do all 6 of them. I'm just going to do B, D, E, and F, which were the ones that were assigned for one of your homeworks. So in the first problem, we're looking at around y equals 2. Not at 2, but around 2. And it turns out this function is continuous around 2. The only place where this function that we're taking the limit of is not continuous is when y is negative 2. But around 2, everything's nice and connected. So in that case, I can actually solve part B. Let me rewrite it here. Y goes to 2, y squared plus 5y plus 6 over y plus 2. I can just plug in 2. So that becomes 2 squared plus 5 times 2 plus 6 all over 2 plus 2. So that's going to end up being 5 if you work that all the way out. Well, verify graphically just means graph this function and show that right around 2, the y value is right around 5. So I've already typed in this function into the calculator. And if you notice right here at 2, you come up, it looks like 5 right there. So that would be good verification graphically. By the way, this graph is not entirely accurate because at negative 2, when y is negative 2, right here, it looks like the y value is defined, but really there's a little hole right there. And if we went to the table and scrolled up to negative 2, you'd see, look, there's an error right there. So, okay, in D, we've got a function, let's see, the function is x minus 1 over x squared minus 1. Now, if I factor this function a little bit, the denominator in particular, x minus 1 over x plus 1, x minus 1. Notice this graph has a hole when x equals 1. So I can't just plug in 1, but what I can do, so this function right here, it's got some hole at x equals 1. So if I wanted to figure out what values are right around it, well then if I could just come up with an equivalent function except that it's filled in there, well that's the same thing as when I cancel the x minus 1, so I get 1 over x plus 1. That's now, this function looks exactly the same but filled in, right? So at this point now I can actually plug in the 1 and I just get 1/2. And if I had to verify that graphically, well, let me go back to y equals here and turn off this one. And I've entered it in as y2, and if I graph that guy, well, notice right around 1, the x value, right around x equals 1, the y value sure looks like it's between 1 and 2 to me. Now, if I actually went to the table, though, notice when you're at 1, you get an error. Real close to 1, when it's 0, when it's 2, you're around 0.5. Right? But you can't actually plug in the 1 into the original function, which is what I've input for y1 here, the original function. Okay, let's look at E. So E, limit as x goes to 0 of 5x cubed plus 8x squared all over 3x to the 4th minus 16x squared. So this one, I don't really know what to do other than factor. So let's do some factoring. So if I factor out an x squared from the top, I get 5x plus 8. And if I factor out an x squared from the bottom, I get 3x squared minus 16. Okay, well, this is a graph that has a hole at 0, right? Hole right there at 0. Well, if I cancel out those x squareds, then I get rid of the hole. So now this one will be filled in at 0. So that's going to be 5x plus 8 over 3x squared minus 16. Well, since that's filled in at 0, now I can just plug it in. So I get 8 over negative 16, which is negative 1/2. And then I'm done there. And if you were to graph that one, well, let's see. So I'll turn off this equation and turn on this one, which is the original function. If we graph that right around 0, it ought to look like negative 1/2, which it does to me right there. It looks awfully like negative 1/2. It actually isn't negative 1/2 because it's actually undefined right there. But right around it, it's negative 1/2. Okay, And then f is the weirdest one, I'd say. Let me shrink these down a little. So f is based on a function x cubed. So let me write this out carefully. So when I say limit as h goes to 0 of f of 2 plus h minus f of 2 all over h, that's really saying limit as h goes to 0 of 2 plus h cubed minus 2 cubed all over h. So that's the same thing. 2 plus h cubed, well, that's really, let's see here. If I think of it as a plus b cubed, well, that's 3 choose 0, a cubed, plus 3 choose 1, a squared b, plus 3 choose 2, ab squared, plus 3 choose 3, b cubed. And this number is 1. These guys are each 3, and this is 1. So this ends up being, and a is 2, so, and b is h. So let's work this out a little more carefully. So this ends up being 1a cubed, which is 1 times 2 cubed, plus 3, a is 2, and b is h, plus 3, a is 2, and b is h. And then 3 choose 3 is 1, and b is h cubed. So then this ends up being 8 plus 12h plus 6h squared plus h cubed. So now I can plug that in for the 2 plus h cubed part. So this ends up being limit as h, goes to 0 of 8 plus 12h plus 6h squared plus h cubed minus 8. That's this part, all over h. So then the 8's cancel. And then if I factor out an h from the numerator, I'm going to get limit as h goes to 0, h, 12 plus 6h plus h squared all over h. And then this has a hole at 0. But if I cancel the h's, then I fill in the hole. So now when I ask what happens right around 0, well, I can just plug in 0 into my modified function. So I get 12 plus 6 times 0 plus 0 squared, which is 12. And then that's it. And to verify graphically, let me turn on the bottom equation here. This is the original. And if I graph it, I can't actually see what happens around 0 there. So let me set up my window so that I can go a little bit higher. So don't care what the y min is. I'll raise that up. And we'll go up to like 20 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like it crosses right around 12. It just so happens, though, that if you plug in 0, you actually get an error because at 12, it doesn't exist. Or at 0, it doesn't exist. But just to the left and to the right, it gets really close to 12. Okay, hope that helps. And I need to turn this off somehow.